Hello, and welcome to Fingerprints Technology Update. We're very glad that so many of you could join us, even though this is the November school break in Sweden. Thanks to everyone for joining. So today we'll be focusing on the future. We'll be showing you some of the possibilities of the new technology we're developing as we broaden our business to become a leading biometrics company. We'll be discussing new biometric modalities as well as new application areas. And our agenda looks like this. First, Christian Fredriksson, our CEO, will talk about our strategic priorities moving forward and key technology. Then Vivek Khandelwal, who is Vice President of Product and Business Functions, will talk about our touchless biometric technology, which is iris recognition. And lastly, Farsan Gavanini, Senior Manager in our transducer technology development, will talk about our In-Dislay technology. We'll be taking questions after Vivek's and Farsan's presentations, and Christian will be taking questions at the end of the session. So with that, I will hand over to Christian Fredriksson, our CEO.
Yes, thank you. Thank you, Stefan, and welcome everybody, also online. Good to have you here. Great day for us again. We're at heart engineers, and high-tech is what excites us, what we're passionate about. And it is an incredible industry and always so fun to discuss in this area. I'm going to run through quite a few things with you, and then Vivek and Farsan will cut even deeper on two specific areas that we wanted to do this. Last time we did this with about technology was actually about a year ago in December. And quite a lot has happened, as it always does in high-tech. It certainly has been a wild and turbulent year for us as a company as well. And there's a lot of investments we've done in R&D, and we wanted to show you a little bit of glimpse of what we are doing here in Fingerprint Cards. Let me talk about the journey of our company. If you start from the left, as I said, this is what excites us. This is what makes our blood pump. We have been in capacitive sensors in mobile for quite a while. It has been an incredible growth to see that happen in mobile. We have started to do capacitive sensors in other parts as well. Now, as a company, we see ourselves moving towards biometric multimodalities, which is already happening as of, in a way, today, the first ones. Not only with some other company launches, but we also launch now with Japan, with an OEM, we launched actually multimodality for us. First time in our time when we have both fingerprint sensors and iris in the same mobile phone. And of course, when we move to multimodalities, we have a few core things that we're expanding our business with. You have to remember that when we look at the capacitive sensors in mobile here, about half of our R&D is doing other things now. And the other things are the ones that you see in the right here. So that's smart cards, which on single-handedly is, as we believe, going to be as big a market as an opportunity as it is in the mobile business of today. Touchless, which is of course more than iris. It's also different kind of face solutions, but we will talk about iris today on touchless. Although we of course are looking at everything around touchless for us. Multimodality doesn't mean two modalities. It means several modalities for us if you want to be the leader in this industry. Internet of Things, basically everything with electricity. Any device that carries electricity will be connected. It doesn't always make sense, but it will be connected to the internet. And it will carry data. And because data is the new oil, everybody will gather that information and start to gather information, right? And then, of course, as an extension of capacitive technology that we have, we talk about the In-Dislay now, and ultrasonic, which we will talk about today, technology we have developed. But that's not all. We're going to continue our road towards being the identity provider. We want to be the FPC inside or verified by FPC. That means we will build cloud solutions. But that's not even that far away. We already have them. We have the first pilots running on with Iris, and we have built our own pilots now for fingerprint sensors as well to do cloud solutions. That gives us a new opportunity in both business models into smart cities, as well as offering application and service providers to do things upon the platform. That is kind of the biometric identity that we want to bring, being that provider, as well as, of course, it requires high security. We call it even cybersecurity. That's the journey we are on. Now, when I'm going to talk today, I'm going to talk through a few things. I'll talk still shortly about the capacitive sensors, because if about half of our investments are outside of mobile and capacitive, then of course it means still that we are investing quite a lot still also in capacitive sensors, even within mobile. Payments and smart cards specifically, I'll talk about that. We'll talk about touchless IO and IoT Cloud, as well as in-display. I already mentioned the reallocation of our R&D, which has been happening in the last year. And then, of course, we expect around 10% of our revenues in 2018 to come outside the capacitive and the mobile. So that kind of gives an indication of a little bit of where it starts to move also the other parts of the businesses for us. I wanted to mention this as well. We have great engineers in the company. Of our R&D forces, 25% carry PhDs, and we're very proud of the innovation capabilities of those teams. And I'm so happy to be part of presenting what those people do everyday lives, and I get to explain that today a bit. That's what's so wonderful in a job like this. I am the megaphone of what those people do, and I get the opportunity to explain a bit of that. And patent strategy is, of course, essential for us. We do that within a broad range of technologies, of course, looking at what I just showed you in our strategy. Those are the areas where we are also have been for quite a while and are continuously applying for patents. We're doing this on a global level, whether it's in US, Europe, or some Asian countries, of course, in terms of trying to build a strong patent portfolio. We have 198 granted patents after today, and we are expecting to receive more than 25 still in this year. And we are accelerating the rate of patents also in the new areas. And of course, when we talk about the ultrasonic, we have many patents and also pending in that space. That's a bit about the patent strategy for us. Let me say a few words about the capacitive sensors. This is, of course, what most people also online and what most people here in the audience, this is what everybody knows about. And but still a few short words, only on this one slide. We said, as we said in the quarterly, in the Q3, we expect to be overall the whole market for capacitive sensors to be below 750 million units in 2017. We still expect growth in volumes. We still expect growth in volumes of about, and we estimate it to be about 20% growth in the volumes going into 2018 of fingerprint sensors, right? So still a growth in volumes. But this is a commodity market, and we have seen the turbulence of that in this year, even ourselves, right? So clearly ASP decline will continue in this industry. We also see a consolidation phase happening, which is also a dropout phase. The volumes are gathering in lesser hands, when the production capability and the R&D investments are not there for everyone to do. As well as also we see that in our partners now, where there are even financial troubles for some players. And that, I suppose, is part of a commodity industry, which is very much what this is now in. We still see strong market drivers in this industry. Reliability, flexibility, and speed, and the opportunity to go with sensors on the front side, under glass, side buttons, and back of the phone as it is today. And clearly cost efficiency and driving that. There is still a lot of innovation that we can do both in cost efficiency and continuously keeping high security. We have the best security when it comes to capacitive sensors by far. We see that over and over again, and it is not a small thing to have. Clearly, we are the market leader in this part of the industry, and we intend to remain so. And we will drive efficient and high productions in our factory partners, and our system technology capabilities and customer relationships will, I believe, help us maintain that. But let me get on to the other parts of the business. I'll start with the smart cards, where we can sense the same kind of buzz as we sensed about 4 years ago before the mobile phone and fingerprint sensors took off, the biometry into smart cards. This is an exciting area for us, and it will take time still before it gets to big volumes. But just showing you a bit of what consumers think when we have done, together with partners, we looked at the market. So what do they see happening in 3 years? Clearly cash is losing out, which is not a surprise to anybody. I suppose that what we see is actually that still the contactless actually shows great interest from consumers as well. There are differences, of course, between regions when you look at this, but we see about plus 50% increase in interest towards using contactless payment cards as well. And then you have mobile payment, which is increasing in interest, obviously, and there is a big usage difference here between regions if you look at China, for example, which you are all well aware. Let me say a few words then on the payment and the industry, and especially smart cards then. How do we see that market? Just to remind you, this is roughly 4 billion smart cards produced per year, and 3.5 billion are payment cards. 500 million are access cards, smart access cards. We see the commercial deliveries happening in 2018, and we have a lot of trials and pilots and going on. The first smaller orders have started in 2017, but the larger volumes, because this is a big industry and it takes time to get going. We see the bigger parts of it in 2019 and 2020. But this is a market with high growth, no doubt about it. The market drivers, convenience and security. I have tried these cars, and those for you who are here can also try the demos, right? So when you're going to put hundreds of billions of dollars into this and use biometry in it, it of course needs to work. And when I tried it myself as well, it really works. It works well and fast and every time. And that's of course the basics of this one to ever take off. We believe that it's going to be contact and contactless. Clearly we are the leader when it comes to contactless now, because then we can take away the cap that is out there and you can actually start using them. There are still areas, a lot of retail who are not using the contactless because there is a cap, and the consumers don't want that. They don't understand the difference between having different payment amounts on how you do it. I talked about this before, reducing fraud. Nothing is as easy as hacking a 4-digit PIN. And every year, the hackers get smarter and better. So if you don't move the needle on the defense, it's going to get easier and easier, which means that the fraud will only go up. So clearly, you need to do new things in terms of the card industry as well to keep the fraud not going up. We see that there is also for the card industry a lot of new innovation and revenue opportunities by using this one. Our strengths, wow. Clearly the strong experience in volume production, very strong hardware and stable software capabilities. And nobody offers biometric performance on such low computing and power environment that we can do. The low power consumption is essential in smart cards because obviously you have a lot more power to use in a mobile phone than what you have in a smart card. So actually when you harvest it from the terminals, you need to have that capability. And finally, which we have learned from the mobile phone industry, and we can see that if ever even more, it is the collaboration in the smart card industry to get the whole industry moving, which is so important for us. We cannot do it alone, so us working across the chain, I'm going to explain that once again because that is so key for us. So when we are mobilizing the whole smart card value chain, let me say a few words around this one because this shows you actually why it takes time. This is a big value chain that needs to get moving at the same time finally to produce the cards. If I start from the left here and also looking at where we are. First of all, we are in all parts of the value chain working with all of the partners. We are the biggest player in the biometric industry, so obviously we are and will be working with the biggest partners to get things going. And that's why I said that the activity level has risen so high. the interest is so strong, and so many of the other players are now working to get these out, that we also sense that more. But clearly, we are part of this industry, and hence, all of us need to get this working. Today, if you look at the solution providers, to mention NXP, which we just announced the collaboration together. NXP, of course, is the biggest player in the secure element market, right? So they are doing the secure element, and they've done power harvesting, and they have done that part. We have, of course, announced earlier already the cooperation with Tshape and the first orders in the industry that they have gotten. So the solution providers, of which we are one, and we are doing then the hardware, putting together the algorithms and the software, as well as packaging the whole part of the sensor. But this is not trivial. You need to do all this in an existing manufacturing system, because it is a very mean and lean industry to produce cards. So you cannot go there and just give a sensor to somebody and hope that they will be able to produce it. With our strong presence and work with all the manufacturing capabilities, we are going through machine by machine, how do you adapt and how do we bring our capabilities so that you can produce in millions the smart cards as well with a biometric sensor, and that it gets through all the rigid quality requirements. So we work together with the card manufacturers as well. IDEMIA, you have seen the F-Card. You have seen Konai that we have announced before as well. We're, of course, talking to all the big players in the industry here as well. And then finally, you have the card issuers, the banks, the corporations, governments, and retail, who are doing then the cards actually over and doing that together with the card holders. And then you have the payment schemes who are taking who are running it and who are actually having all of the liabilities in a way as well, whether it's the MasterCards, the Visas, etc. in this industry. And you have the standardization bodies, which we have now joined these ones, as you see here, so that we can actually also help drive the standardization so that this whole process works. So it's a substantial work that has been done there. And with all those partnerships that we have, we can feel and sense that we are all over in the key of the value chain. In a way, this has a lot of similarities to the mobile phone industry. If I look at the flow, there is a lot of players that need to be working together to get to finally getting and producing these brilliant biometric cards to the industry and to the consumers and their hands. And we realize that the amounts of money that will have to go through this, the hundreds of billions of dollars, we don't want queues to be there when people are going to pay. We want it to be smooth, fast, and it will be much more secure than seen before when it comes to PIN codes and so forth in this industry. We have said many times, I said it so too, I hate PIN codes and passwords, and I want to see them gone one day in my life. We have launched a product here earlier, the Tshape. What a beautiful name, Tshape. This is for high volume production in smart cards. It is easy to integrate into the factories, into machinery, existing machinery. It is going to be existing points of sales terminals that you can use out there in the retail. It is the lowest total card cost. It is, I dare to say, ultra low power consumption, right? Because you don't have much power to take when you harvest it, for example, a contactless card. And still, with all that, we will get superior image quality and biometric performance. We wanted to show you a video animation, actually, of what it means. This is not only about the sensor, but just showing you one piece of what we need to do to make this happen, right? Because we're bringing a biometric performance and a sensor into a totally different environment than it has been before. Bendable, it will have to hold for wear and tear for 3 years and still keep the performance. So let us show you this one. You know, as engineers, we love this. I realize that not everybody is as excited as us always about bringing sensors into some part of the industry. But once again, on smart cards, this will be a great industry to get into with biometric sensing. And I'm very happy about the buzz that we have in that industry. Having said that, still it's going to take us time to get into volume, bigger volumes, as we would say, comparable to where we are in the mobile industry. Now let me talk about the IoT and cloud, which are of course connected in a way. And I'll talk also about a little bit what we have done and what we are doing in that industry. Cloud obviously has to do with IoT, as I said, because data is the new oil. And that means that everybody is gathering data when they connect the devices now. Actually, they shouldn't gather data always. From a cybersecurity point, from a security point of view, you should only gather the data you need. But it has become, in some part of the industry, is crazy. We are very, very clear about following the privacy rules and how do we work in the biometric space. But when I'll talk about this market size, let me say a few words first on IoT, Internet of Things, right? It's very hard to give a market size on how biometric will come into such a big animal, which will be billions of units in itself, which is IoT. So we try to look at it as from some parts of it. IoT will actually be a good portion of the 10% of our revenues for next year. So it's not insignificant anymore. And things which sound interesting, like door locks and bank applications, will actually, only those two combined from the whole IoT market will be between 5 to 10 million units. We estimate the deliveries of biometric sensors into that market next year alone. And it is growing. It is growing well. So it is a fragmented market. And we see also different business models going into that one. I'll talk especially about cloud a bit more when I talk about the business models. And we're talking about transaction-based, we're talking about user-based, we're talking about software as a service, and even yearly fees when we get into that part of the industry. Very much of this is still in the startup, but as I said, we are also going to see revenues for ourselves of this already next year. Clearly, market drivers in this space is security, cost efficiency, and we'll see, of course, public cloud deployments like in the smart car industry. As I said, IoT in itself drives cloud solutions because you want to gather the data and it needs to be protected and well done, and biometric comes in as a very important part here. Now, clearly, we have a strong position to get in here, and we're already doing well in this part of the industry, and the capacitive sensors are doing well. I'll show you a few examples. Understanding the system level performance in these different parts, understanding the cloud, how do you build virtual networks, all of this is very interesting and of course very important to be able to do that. We don't have all the competencies needed, so we will partner, but we have been able to do already so that we have built our own cloud solutions. Of course, you need to understand the essence of biometry. How do you get the biometric identity? And of course, you need then to have some of the endpoints, if I would say. How do you gather that information as well when it comes to iris and fingerprint sensing? I'm just going to skim through a few of the applications. I said that the door locks is interesting. It is not as big in Europe, but it's big in Asia. So when they big housing now and they big bulk of flats, is actually a lot of fingerprint sensors that go in there. As I said, the overall market is between 5 to 10 million units next year. So it's quite many units that are actually having already this one when it comes to that. Also bank applications where it's a secure access that they are checking, right? There are certain boxes with a cloud application, and then when you have to identify yourself before you actually get into buildings or actually get into your PC even or into your applications. We talked about PC. Of course, the PC market is an existing market. It's not going to be a huge market, but it's still a good place to be for us as well when it comes to that. So we have launched, of course, with Huawei and Samsung's on different PCs or laptops. And then, of course, the Microsoft where you have seen us with the keyboard. We will see other kind of funny applications coming our way where we actually get the biometric module into different places, which will not be so big in units maybe. But of course, the ASP is very different from what it is in the mobile phone industry, in all of the IoT industry. It is, of course, it is even multiple when it comes to ASPs. And we will see all kind of different funny solutions actually, where you can use fingerprint sensing. You combine that with a mobile app and Bluetooth, and you start using all kind of industry things that we have. You can see demos here as well today, by the way, on some of these. Gaming industry, and not only using gaming when you get to virtual reality, when you get to actually having headsets and then you will use iris, but also here on the mouse. Blazol mouse here actually, which is being launched, which basically is using you for gaming, so your profile gets updated automatically when you use. So several people can use the same mouses or the same consoles, and they switch, and the user is identified when they get into it, and makes it of course much more cool to do that automatically. Let me show you another video a bit here.
Just about everything we do in life, we do and solve with the most basic human interface available. You, your hands, and your fingers. These fantastic capabilities can become even more fantastic with new innovations focusing on solving everyday problems, where you are the key to the future. With Fingerprints Biometric Module, you can make things genius. Our technology is used billions of times every day in smartphones all over the world. But with your smartness, it can be found in billions of other applications. There are virtually no limits on where to place it. It's compact and fits everywhere and in any design. You being the key brings an all-new level of convenience, and making everyday things easier is making life more convenient. With this out-of-the-box biometric solution, you get everything you need to make the next big thing, used billions of times every day. Fingerprints Biometric Module Dev Kit. Add the human touch and make things genius.
Now when we talk about IoT, it has been talked a lot, so in a way it's not very new that we take capacitive. I suppose the new is that now finally it is moving, and we see actually volumes happening in this part of the industry. I wanted to talk one thing which is interesting, which is kind of the third step for us, which is going into biometric identification, FPC verified. Now when you talk about cloud, I'll give you some both from what we're doing here is actually we have today, we're running pilots, and we have a solution where you basically can gather the iris data from endpoints, and you take it into a cloud, and we can do biometric identification towards that. We have those in pilots outside. We will see our first commercial deals done next year. We will see our first revenues running next year also on these kind of solutions. And we're talking about border control solutions, deals with governments. And just to give you a picture what kind of level we are, we can do, I'll give you an example. If you take on our server now, you take a 4-core CPU, and we can run that. That's basically a PC. You can have that on a PC, right? That kind of capacity of today typically. So we will run with that. We can do biometric identification for about 4 million identifications per second. That's kind of the level that we are out there right now, and what we will, as I said, we're running the pilots, we will have these solutions commercial, and the first revenue is running for us next year as well in this one. And then, of course, we're expanding into governments and border control, and well as opening up the capabilities for us to get into smart cities, right? Which is very different from what we have been in before as being just into semiconductor business, shipping sensors. We see this going into many companies if I look at it. Now we have already banks who are doing access control, but we will see apartments, houses, where you basically register yourself once and you can use them. In hotels, you will get access to certain places. In casinos, you will play or pay in certain places and have access to other places. You will see it in the automotive, in car rentals, and so forth. And then, of course, we have seen now some banks are actually doing public gatherings. For football stadium, you will see different ways of getting access and identifying people as well. Because this is not only about security, but it is also about safety, this industry. And we need to be part of that one, and we want to be part of that one as well. We will also want to look at how can we open up these applications so that when we get the cloud running, that actually other companies can build upon it so that they can actually run their own applications. And the only thing we do is the verification. So we just prove that you are you. You are who you say you are. And that's kind of the additional thing that we bring into this one. As I said, governments are becoming now part of our kind of access, and we will see already going into next year our first contracts with governments and border control kind of city. Smart cities are, of course, a big event in itself, whether it's cars and trucks and so forth, where you will do identification of drivers and you will actually do car fleet management and so forth. So this one is a big interesting area for us. We are there with Iris already today. We have the solution. It is piloted, and we are doing internal pilots now and also doing the same with the fingerprint sensing. I will talk shortly about the automotive. That is, of course, still a while away before you get there because of the long cycles in the car industry. We have shown with Continental, for example, we have shown in Shanghai, we showed how you can start a car with the fingerprint, and we showed in Las Vegas actually at the beginning of the year with Hyundai how you can actually do once registering by actually the steering wheel, you can actually then use all parts of the car after that with the fingerprint sensing. We had also worked together with Gentex actually to put iris in the rear view mirror, and then you can actually connect that to a home system. So what it means is that when you are there, you can go through tolls and it takes automatic payments. It registers actually, or it has a good angle and registration of the iris with the rear view mirror, up to 80 centimeters, and even a little bit more we can actually do from the rear view mirror. And even if you are moving quite a lot, we will register it. And you can do that when you come home. Your home automation, your alarm systems will go off, your garage will open because you have been registered as a driver through your iris actually. And that's, of course, something which we are also very much into it. You can see many other things which are coming, car sharing pools and so forth, driving autonomous vehicles. How do you get registered when you drive them, and what kind of rights do you have? Maybe you will have when your son drives, you will have a little bit, son or daughter drives, they will have a little bit less power in the car and less speed in the car, whereas you will have higher speed and so forth. So there will be many different setups that are coming there. And let me say a few words on before we get. Also, Vivek will talk about the iris. So just a few words on from my behalf as well on where we are with the whole touchless. As I said, we're looking at multimodality, so it doesn't mean only fingerprint sensing and iris for us, but this is where we are right now. And in touchless, we have iris, of course. If I then take a look at what we see in the iris space specifically, is that we are looking at, we believe and estimate there will be over 80 million units ships in the mobile industry when it comes to the iris. That includes, of course, Samsung, which is a big portion actually of it because they have gone quite far on this one. We see clearly the market drivers are touchless now, And of course, face obviously is going to be also a big part when it comes to both mobiles, especially now in mobiles, of course. There is clearly with iris, there is nothing in the human body. There is nothing touchless in the human body that is as secure and safe as iris. The next phase would be to take DNA, but that's not touchless, that's for sure, at the moment at least. So that's going to take a while. And it is also the only part of the body, if you look at what we can see from here, which actually doesn't change by aging. So everything else, when we go along in our lives, it keeps changing, but iris doesn't. This is great for high security environments, and of course with iris we can increase the demographic coverage for ourselves. Now we will expand customers, and of course the launch now multimodality with both fingerprint sensor and iris was a good step for us, which we expected and should be doing. We have many pilots, over 10 pilots going on now in different cases where we of course will continue expanding on this technology. We are the leader also in iris and a strong IP portfolio here. And we have an existing customer base which we can build upon now. And we can go outside of the mobile, as I just said. This also brings a combination when it comes to added security or different kind of use cases when you look at the combining the fingerprint sensor and the iris. So that's also very interesting for us and our customers as well. And touchless in itself is an interesting modality to bring to the market now. And then when I talk about security, I'll just show you what kind of level of security we are talking about. It is something that has not been seen before. We have a term in this industry called FAR, false acceptance rate. And basically, typically, you look at 1 to 50,000 or 1 to 100,000 with fingerprint sensors, right? With fingerprint sensors, we can do 1 to 100,000, and then you can increase as well from that. 2D phase has been 10,000, a little bit more. And now, so of course, we saw that with 3D phase, you will get higher. Even with one player in the industry saying that they can do 1 to 1 million. With iris, you can do FAR 1 to 1 billion. I have to repeat that. Think about it for a second. 1 to 1 billion. That means, FAR means that in one situation out of 1 billion, somebody will be able to come through and falsify in your name. One chance in 1 billion that somebody will get through. Now, first question is, of course, how do you even test this? How could we even test this? Well, the answer is we can't. We don't have this kind of data. We don't have the data available to even run this kind of test. So we have been helped. I'm very pleased by that, by the US government and NIST. And they have been running the test with over 30 billion tests. So this is real, relevant, comparable, actual data to claim 1 in 1 billion. And that tells you the level of security. And as I said, there is nothing else in biometry. And then I'll give you the PIN code, the 4 PIN code. That's 1 in 10,000. Just to give you a picture of the level of security. And then you remember that hackers get better all the time. Computing power increases, opportunities get better, more money coming in. So if you don't move the needle, it's going to get worse when it comes to security. That's the only thing I learned in security industry. You better keep on running because the pole and the goal line is moving all the time. And this is a great way to give over, I think, to Vivek with actually showing this one. So when it comes to iris now, Vivek, he has been a long time from when we acquired Delta ID, a long industry veteran as well. So Vivek will take on here, please. And I'll continue in a while.
Thank you, Christian, and a very good afternoon to all of you and all those online. It's my pleasure to join the Fingerprints team recently, and a great opportunity here to talk to all of you. Let me start with a video. We've been seeing authentication and security as part of the mobile platform from the very beginning. We've seen PINs, 4-digit and 6-digit passcodes that we all love to hate. They've been around. Then came fingerprints in the form of swipe sensors that consumers hated. Then finally we reached a point where good fingerprint touch technology came and became an integral part of the mobile platform. In the last 1 year, we are seeing a new trend where it's not just fingerprints, but a touchless interaction is also being added to the mobile platform. And we have seen various devices with what we call multimodal biometric capabilities that include fingerprint touch, iris, and perhaps other biometric modalities. So why do we need multimodal? And it actually comes down to consumers. Consumers are asking, and increasingly more, asking us to provide a more convenient experience when it comes to authentication and security. They want speed, they want ease of use, and high security. This is something that fingerprints deliver with very high convenience. As you can see, a consumer perception map that has been shown before also in these presentations. Iris at some point was considered on the left of this chart towards low convenience, and that's where the role of active iris that has become a part of fingerprint by the virtue of acquisition of Delta ID. Delta ID was singularly focused on moving that convenience to the rightmost corner over there. And today at FPC Fingerprints, we have both iris and fingerprints that provide a combination of both high security and high convenience. Now, today, we are using multimodal biometrics for convenience to work across different usage scenarios, conditions such as if your hands are wet or you're wearing a glove, you might like to use iris, or if your phone is in a certain situation that you don't have a clear view of your eyes, then you could just touch and unlock that device. You can do that with some of the devices that are available in the market today. But where we see this future, this trend moving, is even further. And in future devices, applications, and use cases, we believe there will probably be a use case where both fingerprints and iris will be used together. And these could be, you can imagine, high-value transactions. We all are using our mobile devices for, increasingly more interesting, important transactions, or log into various sites or applications where we have huge transactions. I mean, I can talk about myself. I have stopped using my web login because I have this fingerprint-based access to my banking applications on a mobile device. Just because I don't remember passwords, now I am registered, I would use that. So we are increasingly using our mobile devices for more interesting use cases. And we see a future where you'll be using both modalities, perhaps, depending on the kind of applications you might be using. Active iris, let me share a few things about and give you a background on active iris technology. It is the world's first iris recognition system for the mobile platform. The company, Delta ID, when it was founded, was singularly focused on bringing iris to a mobile platform. Now being part of Fingerprints, we have completed a solution, created a complete integration for Android platform where it is now available as a multimodal solution. Iris the active iris technology has been built on a strong IP portfolio. There are more than 25 patents that have been filed or granted. Some of the patents cover not just the software but the hardware side also. Some of the foundational patents on how you would bring iris recognition into a mobile platform. Iris, if you can recall, the previous use cases were in the government or border control kind of applications. There were huge devices using optics and hardware that was very different. All that has changed, and now it has come into this very thin device. So there has been a lot of work that has been done, and some of the foundational patterns on how you would bring iris into such a thin device are something that Active Iris is based on, and we have at Fingerprints now own those patents. It is a cost-effective solution. I'm going to share some more details on how this solution works, what kind of hardware it uses. And it has been certified by Aadhaar. For some of you who may not know Aadhaar, this is a biometric authentication system for residents of India, which has more than I think about 1.2 billion people enrolled in this system already. And it is being used. Today, they are doing about 10 million authentications per day. And the system has been put in place to do about 100 million transactions per day. So there's biometric authentication happening for everything like, getting a SIM card activated. For security purpose, you want to know who exactly is the owner of that particular SIM card, because a lot of things happen over airwaves from a security perspective. The government wants to watch that. You can get food subsidies. You can prove yourself to be alive and get your subsidies or pension funds, pension money granted to you. So those kind of use cases are happening there. And the Active Iris system was the first iris recognition system and the first system for a mobile device that has been certified. And we are working with our various OEM customers on various products that are getting ready. They're in the process of certification, final process, and we will see some launches in that space. Let me talk to you about how the Active Iris system works. There's really 3 core components. If you follow the picture on the right of the screen, there is the infrared LED. Infrared LED is essentially an illuminator. It is throwing light at your eyes, illuminating your eyes, using a near infrared light wave. It's actually 810 nanometer. And what that does is it shows the pattern of the iris, even for people with black eyes like myself. Right? You can't really see pattern in my eyes, but at 810 nanometer, you can see that pattern. So it's an illuminator that is emitting light at that frequency. And then there's a camera. This camera is not different from any other camera system you will find in a typical mobile device. We require a minimum of 2 megapixel camera, which is very common, more than 1 billion sold and deployed in various devices. This camera system, the only thing that is configured differently to enable iris is it filters light that is of any other frequency than 810 nanometer. So it basically allows light at 810 nanometer or thereabout within a certain band to go to the silicon behind the filter. So that's the only difference that compared to anything else that you do with a regular camera. And of course, the key component there is the Active Iris software, which is capable of getting these images from this camera system, processing and doing enrollment and identification. We will share with you some of the devices. You might have seen some of the devices that are already there in the market. If not, I have a couple of devices with me. For those in this room could take a look at those. It is actually very fast and easy, and you got to see it to believe it. It works in a very convenient range from 20 centimeter to 40 centimeter range. You can keep the device conveniently as you typically do. The range can be increased, but there is no need because human hands go only to a certain limit. Works with occluded eyes because all of us don't open our eyes. With motion blur, so you could be walking, going down staircases, and still authentication happens outdoor, indoor. It's very safe and secure. Christian talked about low FAR, false accept rates in general with iris, and it's not very different with these devices that we've already launched. Iris in general allows us to expand the demographic coverage for people across different occupations where hands may not necessarily be in the ideal situation to be scanned, or people across various age groups, even twins. Iris works just perfectly fine with twins. The hardware I already shared with you is fairly simple and inexpensive. These are parts that are very common in the industry. The active iris system, another aspect of it is a self-learning system. So once you start using for the first maybe 10, 20 times, it is learning. It is adjusting its internal parameters to make sure it works even better every time you use. So as you go, it starts becoming better and better. The user experience becomes even more user-friendly. In the last 6 months or so, we have also invented and discovered something new that is taking iris recognition to the next level. And that is something that we call anti-spoofing. It's a very important aspect of any biometric system. But this particular anti-spoofing technology that we have put together, and it's in the process of being evaluated in various academic and other studies, uses something called the birefringence property of the cornea. So this is something we found that our cornea, or the material of our eyes, have a certain property when you throw polarized light at it. And it refracts that light based on a peculiar refractive index that it has, which basically means that if somebody else has to show the same behavior, you have to create a material that is very similar to this eye, which is a much steeper challenge for anyone to achieve. So we are in the process of bringing this technology to the market, and we continue to keep the theme of keeping the hardware very simple and inexpensive for even this level of security. Let me compare. We've talked about touchless as a modality, touchless as a way of interaction with mobile devices, and there are more than just iris as a way to achieve a touchless experience for biometric authentication. So on this, we'll compare iris with 2D face, which has been around for a long while, not really used in any significant way, and the more recent news that we've been hearing about 3D face coming into the market. I'll just follow me as I go through this and different aspect and different features of these biometric modalities. Let me compare them for you. As Christian shared, iris can give you a level of security, a level of FAR that is unachievable by any other human part, right? 1 in a billion. And it's very important to know that when you're achieving this 1 in a billion FAR, you're not giving away the usability of that system, which is represented in another number called FRR, false reject rate. A lot of biometric modalities you can dial up the security levels, but what you lose is the usability. With iris, you don't lose usability, and this is something very well understood in the market. We believe 3D face, as has been announced by certain OEMs, is talking about 1 in a million, although it doesn't work for twins. 2D face has an FAR of 1 in 10,000, which is actually not quite usable. This has been rejected by the industry. It has been available for free on Android platform, not being used in any significant way. Iris is very hard to copy and spoof, and we are already talking about an anti-spoofing mechanism that Fingerprints is going to bring into the market, which is even higher than anything we have seen. 3D face, we'll find out as consumers use it. It's a very new technology. With respect to hardware components, I shared in my previous slides, they're really simple camera and an IR LED, which is very inexpensive. If you talk to anyone in the industry, these are like, about sub $5 range, depending on the volumes. Of course, 2D face is, while it doesn't have the level of security that we desire, but it does not require any special hardware. So it is that way very strong when it comes to providing you some form of authentication using just the regular camera that you have on a mobile device. 3D face, you can't say the same, because in order to get 3D information, there are very special hardware being used. In some of the examples we are seeing in the industry, the structured light sources that are trying to read the contours of your face, all that adds to the cost in significant ways. The simple components, of course, translate into lower cost for Iris. Can't say the same for 3D. It is certainly quite expensive, those kind of special parts. The performance, as some of you might be able to experience today, I would encourage all of you to come by. We have some devices, and you can see for yourself the speed at which Iris works. That translates into usability for users who are using this solution. We believe it is certainly comparable, if not better, to 2D face or 3D face solutions that are appearing in the market. The power consumption is also comparable to any one of these other modalities. In fact, 3D face uses infrared in very similar ways as Iris. Of course, it is doing more with infrared than just that. It is throwing 30,000 dots in a certain case on your face. So they do use a significant amount of power to drive all those kind of things. So in summary, Iris provides for consumers a very fast, easy to use, and a safe and secure way for authentication. And for OEMs, because of the virtue of hardware being so simple and inexpensive and something they've used in the past, it is simple, easy to integrate, and low cost. So with that, I'll be happy to take questions, and Christian will join me on the stage here.
Yeah, we thought we would take some Iris now when Vivek is on, and then we'll take hopefully the other questions when we get to the end of the session, if okay.
Yeah.
Francois, yeah.
Thank you.
Hi
Thank you
there.
for taking my question, Francois from UBS. I have two. The first one is on Iris. From what I understand, is you are purely focused on software, and the hardware is very simple. Maybe that's why you didn't want to invest in this hardware part. But it's still not in place the hardware in the market, especially for mobile. How do you push this hardware implementation? Who do you work with to push this implementation? And don't you think the integration of hardware and software, like it was the case in Fingerprint capacitive, your precise biometrics software partners, previous partners, still a bit maybe in Smart Cards. I don't know how it's going, but don't you think it's going to happen the same kind of integration in the market as it matures? So that's my first question. The second one is on biometric as a service, as you mentioned. I think it's really interesting. But I'm trying to understand who would be your customers, not the end markets, but do you mean that you will compete with Gemalto or Berture, or will they be your clients? Trying to understand the dynamics here and who you would work with.
Well, let me take the first question, which I think were two questions there. So with respect to sensors, Iris system, as it has been developed from the very beginning, the idea was to use very simple hardware, no special hardware. So this hardware is available from more than one vendors. What Fingerprints does is there is a hardware specification, a design guide for OEM customers who understand this domain actually even better. They have played around with cameras and IR LEDs in the past. So all it does is gives them a design guide to put together the hardware. And with software, I think it's a great question. We, prior to the acquisition, we have Delta ID, the company, had worked with various OEMs, going through the process of OEM integration, working with OEM teams. It is a process wherein you bring the hardware and software together. And I think now we have a leverage, and we are already working on projects where both fingerprints and iris algorithms are being packaged in a way that it makes even more easy and convenient for our OEM customers to now use Iris. So they understand the hardware very well. It's commodity hardware, very well understood in the industry, multiple suppliers, and now we are even making software easier to integrate. So let me know if I answered all your questions or
Yeah, and I'll take the other one, right, was on you basically looking at the cloud solutions that we have, for example, and biometric as a service or identity. I think we are not a huge company, so we would, let's say that when I said that we do a 4-core CPU, right, we can do 4 million identity checks in a second. And you, of course, add that to servers. That's a PC size, so you can add. I would see that those would be the partners who actually then deliver and even run those together with the governments, right? So we wouldn't necessarily do all that. We don't have that kind of service organizations, for example, for ourselves. So I think we need to, if we build a cloud solution, we understand biometry, we understand how to safely move it from an endpoint to a cloud. And we understand how to do the identification, but I think that there is a lot more when it comes to the data mining, the artificial intelligence that you need to build upon it, right, so on, and actually to run the whole service in a secure way. I think there are many players to do that, and we would partner with those.
Yeah, thank you, that's great. One last thing on the Iris ISPs, you mentioned in March when you closed the acquisition that it was around $2 for you for the software part, if I remember correctly. Is it still the case, around the same ballpark, or how is it evolving?
I think that like anything, if we've learned something from the past year, commodity market, when you get to bigger volumes, everything is volume related. So I think that there is ASP decline in any part of the industry, wherever you go. We don't want to get into where the ASP is, but for certainly it goes down, and the bigger volumes, the more you will see kind of volume deals done as well, right? Victor,
Yes.
and then I think after Håkan, right? Håvard, right after you had one, and then but Victor first.
Yes, Victor, SEB. Just one question on the market. You write 80 million units. Can you just explain a bit how you think about the market more long term? What areas, what size that might be, and what you're addressing? And
Well,
so
I
on.
think that's, Victor, I knew you would ask it, and it's a tough one. I think that if we look at, that's why we looked at Iris for mobile when we talked about above 80 million units, which is a good number when it comes to the mobile industry. I think outside of that, I think it's too early for us to say. We will see, as I said, even on the cloud, we'll see our first deals going into next year, the first kind of revenues coming. Of course, it starts small with the first deals. But we will have to get back when we also try to understand what size of market that is and how do you even calculate it. Because you will have the service part, you will have actually the module parts, deliveries of those, and identification running. So it's quite a market to try to explain, right? So I think on a capital markets days when we do that, we'll try to open up more what we see. Now we're trying to talk only about 2018. We realize that it's tough enough to understand what the 18 will look at, but we see good growth in there as well. And then I think Håvard, right, you had.
Håvard Nilsson for Carnegie. What kind of FRRs are you pitching to the OEMs for the Iris solution? And have you done any field tests on this? And also, I guess the key question is, how do you prevent the software from being commoditized? And on a technological level, how does it compare to the other solutions out there right now?
Let me take it, and then you can feel free
Sure,
to
I
add.
can add, yeah.
Actually, Iris-enabled mobile phones have been there since 2015. The May of 2015, Fujitsu launched the first mobile phone in the world with Iris capabilities. I have a later version with me. They have been field tested with now millions of customers. But even prior to that, with each one of the OEMs that we have worked with, we've done extensive testing where we would look at data collection and look at FAR and FRR. Different conditions, walking, motion blur, outside, inside, all that included. I have more details I can share with you. But just to give you a summary, it is in the 0.15 to 0.2% in normal conditions like I am in right now, the FRR, at an FAR of 1 in a million. That's the baseline. So what's unique about Iris, this kind of ties into the 1 in a billion that Christian made a remark. If you look at the studies on Iris, you can push that number from 1 in a million all the way to 1 in a billion without losing a lot in terms of NIST testing is showing there is a 2x. So yeah, we can go from 0.2 to 0.4 at a much higher level of security, right? Now the FRR numbers change the moment you start bringing corner cases like direct sunlight and so on and so forth. But even there, we are talking about worst case scenarios where it is 5% kind of a situation in those kind of corner cases. So there's a continuum there, right? You make the situation tougher and tougher, but it doesn't get that worse. And that's unique about while maintaining a 1 in a million false accept rate, right? Yeah. And again, these are things that we are continually improving. There is constant R&D going on, improving these kind of corner situations, improving algorithms for motion blur, and so on and so forth.
And I think on the ASP question, Howard, I think like in obviously market economy works, right? So when you get to volumes, you have price changes and you have ASP decline happening. At the same time, you always need to add into innovation. And then it's, of course, we can see very different ASPs in different industries, actually, because also security is depending on how usage is. If you look at when you get to other cases, like if I look at the border control and others, there's a very different price situation there where the security is such a high value situation. But in mobile, I would see that, of course, you will see ASP decline going on there as well. I think that then you have to have good solutions, like in anything, right?
I guess what I'm trying to get to is how do you prevent this from being a sort of 5-cent type of software piece that goes along with it, and sort of to understand that I need to also understand what's the uniqueness about how you are doing things compared to the rest of the guys. And I get that you need to always keep ahead, but right now what are you doing specifically better?
You want to say a few words?
I just want to give you an example that I just referred to in the presentation. One way we are addressing those kind of dilutions, and they're not as tremendous, given Iris is a new modality. We are adding new features, keeping ahead in terms of anti-spoofing is something we're going to bring to the market. That's an example of how you keep ahead and you keep adding value. In terms of usability, while you may see devices that I have today that have certain read range and certain usability, customers are demanding for even better, and so we are continually improving those kind of things in terms of usability, usage distance, gaze angles, and so on and so forth, to keep the software ahead, which allows us to keep the value intact, right?
I think it's I think so. And I think if you look at, I suppose, Howard, if you look at where we are now, we are by far the leader in Iris. If I look at where we are in terms of performance, in terms of security, and what we can deliver. So I think that's, of course, and we realize it's a moving target all the time. I think that's how the industry works. I think we learned that also in the ongoing year. Yeah.
Yes, just follow up as well. Is there any patents here that you have that you are specifically proud of, or that are really good for you in
yes.
related to Howard's question? And will the market share correlate with smartphone market share, or do you see that this can be separate and sold on to? Can somebody be the winning the fingerprint scanner and then you add the iris, or will it always come as a package, or how do you see that?
Well, I think the second question is easy to answer. You will see many mixes. I don't think it goes. Of course, we want to bring the value of bringing an event together, and making it easier and more cost efficient. Actually, in terms of there's a lot of things we can do with the algos and so forth, right, to combine and get the power of that. But you will see both. I think you will see where we are, both of us, as with now one model, and then you will see separated. I don't think that you will see just they are so tightly packaged. I think that we will have to drive value in it as well, and we will, but it will be still decoupled as well. And then the first question was actually, Victor.
The patents.
The patents. Yeah,
I can talk about, yeah. So we already have about 25 patents granted or pending, depending on the situation. But some of the foundational patents have been granted already. One of them I referred to during the presentation that allows us, we're uniquely positioned to bring Iris on mobile devices. These are foundational patents with respect to how do you configure hardware for such a system. While it's fairly simple hardware, there is a method to that. how to make it work. So we have foundational patents in hardware, in software, some various aspects of software. Another thing unique that you might see with what Delta ID has done is prior to Delta ID, there was people were looking for that pristine frame that you capture and then you do your iris recognition. Delta ID introduced what became a video-based authentication because the mobile platform was allowing you to collect videos at 30 frames per second. So you could do that, right? So there are patents that surround that kind of iris recognition system. You can find some of this information online, but there's a significant body of patents there. We've been adding that. The birefringence thing is a pending patent right now. So we've been adding to our patent portfolio on an ongoing basis. Like Christian said, I mean, this is an activity that is across the company now. So
Yeah, and I have to say that we did I would dare to say a fairly thorough check on patent before the acquisition, and we actually scanned the whole world. We used a substantial amount of effort and technical evaluation as well, because we realized how important it is to have a strong patent portfolio also in this space, right? That's still the essence, and then of course you need to defend your rigorously. You got to defend, of course, your patent portfolio as well, right? So, but clearly that was one part of the evaluation that they had, because they clearly Delta was the first to move into the mobility, right? And they took a totally different angle. We like that, and also then the patent portfolio was very different. Okay. Yeah, one more here. Let's get the mic.
Martin Lindgren direct. What competitors do you have within Iris, and how large are they, and how large is the market share that you estimate that you can capture next year?
We don't. I think there are quite a few competitors, as there has been also on the fingerprint sensor side. There are more coming, as typically when something starts to move, and non-touchless is more. So we will see more coming, and they will have their challenges with the patents, actually, of course. And there are quite a few, actually. I'm sure Vivek can add on, or don't want to start naming them. And then when it comes to a market share, what we have said all the time is that all the industries that we go into, all the segments that we go into, we want to be the leader, right? We want to take that kind of position. And to be the leader, you typically have to have about 35% that kind of market share in all of the segments, right? But then that requires, if you take Iris, that means, there's going to be automotive, there's going to be mobile, there's going to be many different, so we're kind of capturing that all together in it. So we're not going to give a yearly number on our market share yet. It's too young, too early to say others. It's still a small number, even if it's growing well, but it's very small to start with, of course. There.
You mentioned the figure 80 million next year, including Samsung. How much of that does Samsung constitute, and who is the supplier to Samsung?
Samsung, we have supplied one of the models basically for Samsung.
So actually, with the
I just say on the Samsung still, Samsung is a good portion of it because they have been very early on with Iris. Otherwise, they have their own solution where they have added some patents into it from others, right? So they basically have built their own so far, as well as used ours. But Vivek, yeah.
With Samsung, we have a tablet that was the first mobile device in India to be certified for the Aadhaar iris recognition system. So we've been working with them.
Right, thanks.
Thanks. And then we had Francois still, huh?
I think this is the last question.
Yeah, then we'll...
There will be opportunities to ask more questions at the end as well.
Just a quick follow-up on this Samsung. How do you compare the two technologies, Samsung technologies and yours? Would like to know why it's different, why different than when they do, and why would they choose Delta ID when they have the in-house capabilities? Trying to understand why they do that.
Well, I suppose, at the end of it, you'll have to ask Samsung on their choices. I think that a simple answer is that our solution is better. And that's the short one. It's better. And I think that Samsung has, of course, in many areas they have done their own solution as well, right? And then they also take competitive in. They kind of tend to run that in at the same time. They have that in many of the areas. But then again, they very hard for me to say anything else on behalf of them. They make their choices then, right, as they feel pleased.
Well, I mean, we cannot comment on what's inside Samsung devices that are not using our software. So, but from yeah, I mean, from an as Christian said, when we try to compare the experience, we see some differences. We believe ours is better.
Yeah, that's probably all we can say. But it would be embarrassing if we wouldn't believe that we are better. Of course, we are the best. If we're the best, then we have to be better than that. And with that, Vivek, thank you very much.
Thank you.
And we'll have, of course, Vivek is here for any other questions around this. And I will get to. There is always one more thing. So we had one more thing which we wanted to discuss, and that is the In-Display. We started this and we discussed this actually. This has been a great, fun, challenging journey so far, and it continues for us. We started this actually in end of 2016. That's when we started, and our great teams have worked on this. This has been a big investment for us so far to get where we are in terms of being able to say that we have designed, we have done the technology. Having said that, there is still a way to go, of course, because to productize something and to get it to the right cost, that's a different thing, right? That basically means that you have to go through the whole manufacturing. And because we are doing something very different, basically disruptive from what is there in the industry right now, that requires also partners when it comes to the displays and when it comes to the integration and when it comes to the OEMs. So we will get to the next phase with the OEMs, the partners, the key partners we will have that we will work ourselves through to actually make this a commercial mass production product. So now when we talk about the technology, let me say a few words, right? That because this is of course exciting for us. It is a disruptive. The whole thing we started was that we have to do something which is different. We want to see something which is disruptive. We don't want to do the usual. And we have of course done, as we discussed already in December last year, we looked at both optical and ultrasonic on top of capacitive, and we've invested in that. We believe this will be initially in the high ends, and then it depends on once again, if you look at the capacitive curve, how you learn and how you learn to drive down cost, there is a lot of things that needs to happen before you get to the right levels. Now, the market drivers are quite clear, right? With the full display happening, with a better user experience, with the full screen being used as an industrial design, right? With the new OLED screens coming and the screens getting full, you want to use all the space of the mobile phone. And that's, of course, why the fingerprint sensors have gone to the backside now, because nobody so far has really been able to solve that going through the OLED screens, right? Now, our strength has been, of course, that we understand biometrics and we are the leader. So we felt that, if anybody can take this forward, it has to be us. Now, so what we have done was, let's think differently. Let's not think the way we are today, but do something very differently. And that's why we came up with something that is totally disruptive. It is exciting. It's fun. It's the way high-tech should be. And this basically works anywhere on the display. So you can put even all your fingers on the display. It works both with LCD and OLED panels, and we are doing this with our pilot now. We're going towards the next generation. And it works actually on glass as well as metal. So you can actually even do the backside. And even if we're talking mobile phones as the first way, of course, you can take it to other as well. And for that, I'm going to show you something just show you a picture of what we would love this to be, and give you an idea when we mean disruptive, what we want to build this to, right? This technology of ultrasonic, and that we have taken to now, and that is what's exciting with this one, right? And I will give over to Farzan who has been working with this for all the time. And he was also explaining in December about both optical and ultrasonic at the time. And he and a lot of people, actually, it's a big investment for us that we have put into this, and we will continue putting into this one. So Farzan will explain more about it now. Thanks.
Thank you, Christian. And hello, everybody. Last year in Capital Market Day, I talked about capacitive sensing technology and the challenge it has in front of it for its display integration. Let me start by recapturing that here. So the picture that you see to the left shows the ideal capacitive sensing. You have a number of capacitive pixels that are under a thin layer of insulator. You have a finger on top of that. You have ridges and valleys on that. Each pixel would capacitively couple to whatever happens to be directly on top of that, right? You get different capacitances between different points, and from that you create an image. Now imagine we increase the thickness of this insulating layer. What would you expect to achieve is the same thing. Still, every pixel couples directly with what happens above that. It doesn't happen in reality. What happens then is that every pixel not only couples with whatever happens to be above that, but also it capacitively couples to the surrounding. The consequence of that, which is very important, is that by increasing this thickness, you start to lose contrast, image quality. And when you go above a certain limit, you're not able to make a good image anymore. The reason behind that, as I explained before, is the nature of capacitive sensing that exploits an electrostatic field. You say electrostatic, the name suggests that it's a static field. It does not change with time. You do not have a propagating wave. You do not have a phase front. And by definition, you cannot achieve focusing. This is in contrast to what you have in light and sound. Both of them are dynamic fields. They have a field, they have a wave that propagates. You have a phase front. You can manipulate that to achieve focusing. In light, the element that does that is called a lens. I think you're very familiar with that. In sound, what we call there is called beamforming. So you change and manipulate the phase front to focus the energy at a given point. And therefore, with both of them, you can achieve a focus, an image, at a larger distance. This is the key characteristic that is exploited for in-display fingerprint sensing. Of course, there is no product in the market yet. And by looking at the bulk of research and what's happening out there, you can figure out that the conventional solutions for solving in-display problem is that by getting an ultrasonic sensor or an optical sensor, place it under the display, and then because now you're capable of achieving an image of a finger that happens to be about a millimeter or a bit more on top of this cover glass, then you can make an image, right? And of course, there's a lot of tricks that you have to play to make it work. But this is the principle of what I call conventional solutions. There are a number of important limitations with this that I would like to go through. Number one, in the case of optical solution, your sensor, to function properly, needs to have light to go to it, right? That light has to go through the panel. So more light goes through the panel back towards the sensor, better image you get. Less light, worse image. And in case of panels, such as liquid crystal panels, that there is no light can get through, you cannot create an image. So those optical in-display solutions wouldn't work under an LCD because of that problem. So the most important thing to remember here is that you have a sensor, you have a fingerprint sensor, that its performance is dependent of the panel, of the type of the panel that happens to be above that. The second thing here is that the size of the image is more or less the same as the size of the sensor. And now you want to acquire a fingerprint image and display over entire display, you have to have a sensor which is the size of the display. Most of those sensors are made of silicon. Imagine the cost of a silicon sensor the size of the display. It's the same case for ultrasonic. In optical, we had light-sensitive pixel. In ultrasound, we have sound-sensitive pixels. So those ultrasonic sensors send a signal, send a pulse, that goes through multiple layers in the panel, goes through the cover glass, and gets reflected back from the surface of your finger. That echoes that come back are collected by this sensor, and then is used for creating an image. So now, again, imagine the sound that has to go through directly multiple layers. In case of liquid crystal, for example, you have the liquid problem that scatters the light. So therefore, such sensor cannot work on the liquid crystal panels, which constitute a large proportion of the market today. Again, you want to increase the size and get a fingerprint sensing over the entire display. You have massive number of pixels, of sound pixels, that have to send and receive a signal, a sound signal. The cost of something like that would be huge and very complex to achieve. So by these conventional solutions that I discussed, what you can achieve is what we call a hot zone. So hot zone is an area within your display that is capable of acquiring a fingerprint image. And also, that would be the quality of the image you acquire at that point would be dependent of the type of the panel that you have on top of your sensor. Panel dependence and also limited area, hot zone. This is what you get with these conventional methods. At Fingerprints, we knew when we were developing this technology, we knew early on, if we want to be successful, we have to put aside the conventional way of solving it. We cannot make a sensor for in-display that would be sensitive, that its performance would depend on type of panel. Now, in OLED, for example, now, of course, we have one major player, but in coming years, we have Chinese coming into the market, we have Japanese, and we have multiple Koreans. So you will have many sources of OLED manufacturing, and also you have LCD that is a significant portion of the market still today and will remain so for coming years. So your sensor has to work equally well, regardless of what panel you use. To achieve that, we had to put aside completely the conventional way of solving this and think outside the box. What we achieved was integrating the sensitive elements in a completely different way that is very different from the conventional way of solving it. We generate and we transmit the signals in a very different way than the conventional method. As a result of that, the signal that comes back is not depending on the type of panel you use. That is one of the most important novelties of these technologies. By using a novel integration technique, we get a signal back that is not affected by the type of panel. This is number one. And then I talked about this in my earlier slides, and that was the size of the image is more or less equal to the size of the sensor. So in principle, what you have is a 2D array of pixels that creates a 2D image. Every pixel here correlates to one pixel in the image, right? You have a camera, a good example of that. So you have a 2D image, you have a 2D sensor, you create a 2D result out of that. The problem here would be that if you want to increase the size of this sensor, your area has to increase. The area, when the area increases, the number of pixels you need to have that exponentially increases by increasing the size. So if you want to use the normal 2D array imaging, you explode the number of pixels very quickly when you increase the size. And we knew that this is not going to work if you want to do it over the entire display size. This brings us to the second and one of the most important novelties here. We are not generating a 2D image based on a 2D array. We are making a 2D image from a 1D array of transducer. We collect the raw data, and we have developed a unique technique that converts that raw data that is collected by this 1D array of transducer, and we make a 2D image out of that. The most important consequence of that is that now you can increase the size because the number of pixels you would need now linearly correlates to the size you want to measure. So there is no explosion anymore. In fact, the number of pixels that we have over in our demo unit that we show this is the number of pixels is still very manageable. And that's the key to achieve fingerprint sensing over the entire display. This is the result that we get. This is a true image that we have taken from our demo units as we have been using to show to our key customers. The glass used here is 20,000 micrometer, just to show that the glass thickness is not a problem anymore due to our unique integration technique. 20,000 micrometer is 2 centimeters. And look at the image that you get here. First of all, you have the entire thumb. You have the entire area that is in contact with the glass, because the area is not an issue anymore. You can see the level of details here is very high. In fact, this image is about 1,000 dpi. You can see third level features. Those are the sweat pores, and you have all these small details of a finger that are clearly visible in such image. Compare that to a capacitive sensor, small sensor that is achieved under around 100 micrometer of coating. You can see the difference. I have to say that still, when it comes to standalone buttons, fingerprint sensors, there is nothing that can beat capacitive sensor, because the image that it generates, the quality of the image, and at such level, at such cost level, is unbeatable in principle. But when you go to the in-display sensing, when you go to the thick glass, the rules of the games are different. And such sensor cannot perform as well to this disruptive technology. So there are completely two different games with two different rules. In a standalone button, capacitive, unbeatable. But you go out here, you have different game. So we have developed a technology that enables us to acquire a fingerprint over the entire display area. You can put your finger anywhere on the screen, and you still can get an image, a very high resolution image. And also, the performance of that technology, of the image that you get with that technology, would be independent of the type of panel. Use LCDs or OLEDs, OLEDs from Chinese manufacturers or Korean manufacturers, you get the same results. And of course, this is a great technology we have developed. And we still have a number of challenges to bring this technology to a mass market. And this is what we are working on day and night at Fingerprints. Let me summarize this. We have developed a disruptive technologies that enables acquiring a fingerprint image over the entire display. And that removes the need of a physical button. So the entire front side of the phone is available now to you for making a display everywhere. That's very important. And as I mentioned multiple times, to our knowledge, this is the only technology that can achieve in-display sensing on any type of panel. It performs very well on wet fingers. You can even acquire an image under so when your finger is submerged in water. But it still gives an equal performance on dry fingers compared to the capacitive sensors. It works very well under both metals and glasses. It can work very well under very thick glasses. And it works in contrast to capacitive. It can acquire an image with no problem under metals. So being able to get an image under metal surfaces opens up the applications that you can imagine to a wide range of different applications. And also, we have already demonstrated with the demo that we have and have been using to show to our customers that we can get an image under 20 millimeters of glass. So the glass thickness is not a challenge anymore here. Yeah, I think with that, I would like to give word back to Christian.
Yeah, thanks, Farsan. So, I'm back. And I'm going to just summarize this before we get to other questions and answers. And we can, for those who are here, we can actually look at the demos. Also for the ultrasonic demo, actually, and the first generation of it. Now, once again, this is the journey. This is the excitement that brings us every day to the job and the engineers in what we are doing in this company. We have started a journey from the capacitive sensors, especially in the mobile. And we tried to explain today how we move into multimodality and being the biometric leader there. We're going to add, we see a brilliant opportunity for us in the smart card business, even if it takes a little bit while to get to volume. And now with the first touchless for us, looking at Iris, and then of course looking at how to expand there and the strength of the Iris offering. And then now seeing also the IoT move, and actually even sub-segments within the whole IoT. And then you heard the in-display technology that we are going to now start doing hard work on to get that to a commercial phase. And then, of course, when we do that and go from multimodalities, and we're going to build on this one to become the biometric identity, the FPC inside, when we build that, that's the journey we are on, which actually is far more than only multimodalities. I tried to discuss what we're doing with in terms of the smart cities, actually expanding with our cloud solutions, which we now have in pilots already with customer cases in Iris, and we will see commercial launches of that next year. And we have also the pilots going on internally for the fingerprint sensor, and we are going to expand that with new business models for us as well. And then, of course, even going into application server offerings where you basically can actually let third parties build on it and partners build on, basically having a view of verified by fingerprint cards. We look forward to that journey. And this is, as I've said so many times, this is only the beginning for us, even if we are 20 years down the road. And that's what's so fun about this one. I hope you enjoyed a few of the technology. We want to do this in more regular intervals because there's clearly so much happening. Once again, just to remind you that when we have gone on this one, about half of our R&D force is already doing many things that you have seen a bit of glimpse of today, what this company is doing and what is so fantastic and why we come to work every day with a big smile on the face and what makes us excited about this. And with that, we're going to conclude and get into the questions and answers actually for the whole session here, right? And that was the logic. Also, Stefan is looking at what we have online.
Yeah, let's start with a question from the web. Since you have no in-display product ready, why are you talking about this now?
Yeah, I think that because we've been so long and we have actually put a lot of effort on it already, and we know that it works. The technology works, the image is good quality, which is very important for us. And then we have also now gone into customer discussions, the feedback is very good. And we realized actually that now the next phase will be that we actually go into how do you get that through a manufacturing, how do you get that to a mass production, and we're going to need a lot of partners when we do that. So this is clearly also starting to leak anyhow. The information will leak, so we might as well go out with it as it will come out anyhow now. So we felt that it's better that it comes from us, and instead of being all kind of different rumors, as well as we realize that now in this next phase it will come out.
Thank you. This is Victor Westman from Redeye. The first thing that comes to mind here is, of course, Qualcomm. And I just want to ask there, what gives you the confidence that you can do this better than Qualcomm, since they've been doing this for so long? They invested so much money in ultrasound. And the second question is on the work that you did before in capacitive on software and algorithms. Is that something you can use to a large extent here as well in ultrasound, or do you have to build everything new from the bottom?
I think you can probably Farzan can answer a bit on a very good question on what kind of new competencies, which is of course many new competencies that we have, and it's a big investment for us. But I think on Qualcomm, you know, I'm sure they will. It's a big company; they can speak for themselves, so I don't have to talk about their solution. I think that from our perspective, it's of course a different solution, even if it is ultrasonic. We called it a more traditional way of solving the problem. We are looking at it from a different angle. And I think that, you know, we are the biometric leader. This is what we do. And this is all we do. This is all we are. This is what we live with, you know. That's the bread and butter. That's what we wake up every day, you know. So I think that we feel strong about we're going to solve this in terms of also volume production. That's why we come out with it now. And then what the other guys do, that's more conventional way of solving it, right? I'm sure they will have a lot of resources as well, and I'm sure they will talk about their angle. But Farzan.
Yeah, I can add on the technology comparison. I think I tried to cover that in my presentation. Qualcomm's is the conventional way of using the ultrasonic sensor. As you know, Qualcomm did not develop that technology for in-display. There was a technology was developed for just a standalone fingerprint sensor, and now they are using it for these applications. And due to the origin of this technology that was not originally developed for in-display sensing, it's a lot of challenges they have to solve. And the technology by nature is not really designed for that. So there is a lot of challenges there, as well as I also covered in my presentation. And also, we want full-size display. And you have seen the performance of that sensor 2 years ago, how it was as a standalone sensor.
Yeah, thank you. And just a quick follow-up there on the patent side, is these new disruptive ways to solve it that you have, are those fully patent?
Well, of course, patent is very important for us, and we do have patents there. But it's a very young technology, and one of the reasons that we were very hesitant to go out with it was to make sure that we protect the idea correctly. And this is an ongoing process. And that's one of the reasons I was not able to go into details at all today of how we are achieving this.
Yeah, exactly. But we realize also, by the way, that with this is such a hot topic, and it is the holy grail of in-display that we are going with. We realize that we will not be able to answer a lot of technical questions because we are applying patents. We have applied a lot of patents, and we want to close those going forward as well. But we've done a lot already. But we realize that it's going to leak now anyhow, so we might as well go out with it, but not explain all of the details now as we are doing. But yes, patents are obviously a very important part of this, was to keep ourselves in a strong position there as well. Yeah,
Hi.
Howard.
Howard for Carnegie. Question to Farzan first. Could you sort of walk us through the challenges of bringing this in-display product commercially? And also, what's the sort of ballpark number of pixels you would need to sort of cover the entire, say, conventional screen? And then also perhaps give us some color on what kind of price points you would need to get to. And of course, a time frame would be helpful as well.
Just a few small questions. Yeah.
Well, it would be very difficult for me to talk about challenges without disclosing the things that we are working. But of course, we do have challenges, and we are working on that. And we are bringing a new technology to market. And you can imagine the type of problems you have there and you have to solve before getting there. The number of pixels is a very good question, and I leave it at that point.
Yeah.
I wouldn't be able to give you exact or a bulk number, unfortunately, yet.
Yeah. I suppose on the challenges, it is mainly about the mass production, how to do that. We know, as I said, the technology just works. We get a great image, which is pretty fundamental position to start with, right? And I mean, that's pretty brilliant position to start with, right? So then there's a lot of work, but that's work that needs to be done. But we can't do it on our own because it involves actually the manufacturing process now, because this is disruptive. It doesn't work the same way we've been doing things now for a few years, right? So that's one thing. And on the price levels, I can only say that we get a lot of interest now, and I get exactly that question from the customers. And I give the same smile to them as well. We're not answering the pricing issue yet. Yeah, but obviously it will be more expensive than the capacitive sensors. It will start with that's why we talked about the high end. But clearly there's a big interest to drive it, both from customers and ours, to actually drive it in many segments. But first you got to get started with it, right? So. Time frame is also that we don't want to give the time frame because that's really up to how do we do with the partners. We will choose a few that we will actually now basically do it as we said in the first half. We need to do the actual integration now and get the manufacturing process in place, get those pilots in place, and then we will only, because it's not up to us. So I don't want to give a time schedule and then before we have all of those clear discussions clear. I understand that everybody wants to know when. But no date on that. Synoptics is saying a year or two. Yeah, of course, you can't be too late with this. You know, technology has to. You can't be too late or you can't be too far off, right? In that perspective, we understand that. You know, we can't sit here and explain forever that we can't get the manufacturing going. And I don't want to give a date yet. I'm sure we will be asked that and we will get back to that. But we want to give a real professional date when we get to that one and not just throw something without having the real pilots of what it means for manufacturing. Because it's mass production. You got to do millions of units of it then.
Just a quick question. I understand that you can give an ISP because it's not in the market yet, but you can maybe give us an idea of the cost for you, which is, I don't need like a precise number, like is it 10s, 20s, $30, just to get, I think, an important question to understand the mass production capabilities, just to have a range. So that's the first one. And the second one is if we look at the market today and 3D sensing, facial recognition technology, it's not only authenticate the user, but it's also doing other things. And maybe it's one of the reasons Apple is adopting this technology, because it doesn't do one thing. And, you know, it's less expensive in a way because you do more things. With this in-display, do you think about bringing other things? I don't know. I'm just asking if you are thinking about other things that just authenticate with this new approach of full display.
I suppose on the cost, we don't want to give any numbers yet. We will get back to that in terms of what after many customer discussions. Then what we're gonna say. We realize that there is a certain threshold clearly on how much it can cost to get started. It will be more expensive in the beginning. And I think that as we have seen with capacitive, the once the volume move, things happen. Commodity comes in, and the process gets better. Costs are taken out, so the things move fairly fast. It will be expensive from the beginning, I would believe, much more than what we have in the market right now in terms of capacity, for sure. And then when wait a minute, the second question was more about where can you use and the facial. I think you're very right that 3D face was about. It was not about how do you open up. It's not about open up the phone actually as much as it is about the other things that it brings. Augmented reality, doing games on a different level, and doing all kind of design capabilities and so forth. Right, that you can do with that kind of functionality. So I think that's why we also think it has many other good benefits actually to use the 3D, right? So I think that will come. And then I think what we will do is basically we will learn a lot. I think that the simple answer is that there is a lot you can do with this differently in terms of applications, in terms of capabilities. It's not only restricted to the mobile phone industry, right? And as Farzan was saying, right, we can do all kind of glass, so we can do also metal. So you have, of course, other opportunities to go outside of the mobile industry, and we will, of course, look at that because there are many different use cases that you could have in terms of getting fingerprint sensing into a different place. And then, of course, you can do different things, so even on a mobile, because you can suddenly, when in games and others, you can identify yourself, or you can click, or you can do things directly on the screen everywhere based on what apps are saying to you, and not just driven by the way it works now, right? So I'm sure there's going to be a lot of innovation coming up, even outside of us, in terms of what you can use. And I look forward to all those discussions that we're going to have with customers and partners, because there's a lot of ideas that will flow in that space, right? So I think you're right that this is more than just the capacitive fingerprint sensor in itself, right? But we don't even know all the things that we have ahead of us here.
I can add on top of that exactly is that one of the great potentials that this opens up, you're fusing touch and fingerprint sensing. Imagine you have a bank app that you want to run, you just click on that, and that's all you need to do. You're already given a click, and also you have identified yourself through that click. That's seamless. You can also think about that you always have the access to authenticate the user while you're even typing something, while you're even interacting with your display. That's a great potential that you can tap on, in a number of different ways. Do you have iris for that? Well, but iris, you don't. Here you have to take an action. And there are cases that you're looking at it, you don't want certain thing to happen. You want to be actively doing something, and that's a very important thing. And I think from user experience, it makes a huge difference. By just looking, I don't want to open my bank account, but when I touch it, then I have taken active work.
Victor.
Yes, and just a question on integration. Will it be part of the screen manufacturer to do this, or somebody else to do this, or will it be assembled outside of the normal layers, or just figuring out where in the chain will this new solution be inserted into the phone? How will that work?
Yeah, this is a very good question, obviously, and we are working on that different. But what is the most important for us is that we know that we cannot mess with the display panels in a way that is being manufactured. So whatever we do should be compatible, and should not require any modification on the display panel. So this is our guidance. And how we exactly implement that, I think this is something that we would be able to talk about it in a later time.
Will it be the screen manufacturer that adds this, or will it be the OEMs that adds this in the end, or where in the chain will this be, the ultrasonic be implemented?
Yeah, I think this is something that we are working on right now, and it has to be. There are different opportunities based on exactly how you want to do it. So we are exploring all different paths now.
We don't want to tell basically yet. Thanks, Victor.
May I ask a question on smart cards? Is that okay now? Or?
Of course, anything I think now.
Yeah, so just wondering here, you speak often about hurdles in the value chain here, and that it's more complex and other players here, and a lot of bits and pieces that needs to fall into place before we can see a market blooming, basically. Just wanted to get sort of an update. What pieces have fallen in line so far this year, and what are left, and what is like the biggest thing messing up commercial
I think that what has gone in place is that all parts of the value chain are interested, doing pilots, doing it, right? That's a big difference from earlier. Also, we have a commercial volume production capable sensor, and it works extremely well. All the pilots that we are running, which are substantial pilots now, even manufacturing pilots, are functioning. So kind of the parts are there. Now we have the latest with NXP, right, was that even the secure elements, so the integration of security, all of that, the framework, which is what they have launched, even that works. So all the pieces are falling together, right, in terms of going there. Then the test with the real consumers and the interest of the banks, right, that they can see that this makes sense. That's happening now, right? As we can see with the interest of increasing interest from the banks who are going to issue the cards then to consumers. So many trials. So I think those are the differences what happened. That's what I said, that we feel that a lot of the pieces are coming together as here, right? Which has been it's been a long journey, I have to say.
And last question, just thinking on in general in IoT and smart cards and so on. The onboarding process seems a bit tricky sometimes when you think of the examples.
In the smart cards?
Smart cards or smart locks or whichever really area. How do you feel about that? Do you see that you have clear onboarding plans for when the first time a customer is using it? How's that going to work? You see, or is that a big hurdle that you're still working on?
No, I think now we have. I think that's actually, by the way, Victor, a very good point, that the onboarding, for example, for smart cards, because how do you make sure that if you you get a smart card and then you identify, how do you make sure that you are the one who is first time identifying yourself on it, right? That is the right person. And in some countries it's easier because to take the card you need to go to the bank, so then it's easier to do it there. But now there are actually real processes being tried and a few examples of how it is being done. So I think for smart cards we have a few very working onboarding processes now, which are being tested as well. And then in IoT, of course, we are, if I look at the door locks that are out there, that's already being used. So there is also the onboarding has been tested even. I mean, we're producing. So that's also been its own trial and error actually to get that onboarding better. And you can't go out with some weird machinery suddenly to get that done, for example. It has to be very easy. If it is a smart card that for example, first time you use it, you might have to go and use it, and you have a one-time pin, for example, where you do it, and then you also identify your finger on it. So there are different ways of doing the process now, so that you actually get it going. So yes, that's been its own journey as well, and a good question. Yeah, there is one more.
My question relates to the force that you have within R&D. I see that you had 406 employees by the end of September, and you said now that more than half of the R&D staff are working outside of the capacitive realm. How big is your R&D force now, and how big do you think it will be in a year from now?
I don't think as we said actually after Q3, we're not going to grow our own forces now. We need to, I'm sure that, and also on the capacitive and in the mobile side, I'm sure over time the investments there will start going down. Actually, if I look at the mobile capacitive, we will still do a few generations for sure. So we're about 350 people.
200 or 350?
300 plus people in R&D. And then of course we have a lot of different partners that we are working with as well. So it's not only the own working force, but we are having consultants. We are having other companies which are doing parts of when we do the R&D. So it's a bigger force actually at the end of it. But yeah, so just below 350 people with the consultants, and then plus other partners that we are working with, right? So.
And what do you think about going forward? Will it increase in total or decrease?
No, at the moment we're not looking at increasing. We said that we're not going to increase the cost level now. I think that we have a good enough space now to move. We've used, as I said, around half of the people are already doing outside work, outside of capacitive mobile, which is, of course, tells you how much we have shifted in a year actually on our resources. So we've increased the resources and we shifted the resources. So a big change for us as a company as well to get going on these new areas.
Thanks.
Thanks.
Olof Svanberg, Reuters.
Hi, Olof.
Could you today estimate how much your market share could be affected by this in-display solution of yours?
No, I don't. Olof, I think that's a very sharp question. I wouldn't be able to say now. I think that obviously it's a disruptive technology. Then you have the market share, then you have an ASP effect, right? So there are many things that come into play here. And it would be, of course, starting in the high end. So no, it's too early. First, we have to get it out. We have to get it into volume production. And then... of course, we are excited about it. I know the customers are excited. They want it yesterday, so there is a good discussions to be had there as well.
You didn't want to go too much into detail about the timing of this solution, but could you say what year at least you expect commercial launch and big volumes?
No, I don't want it. I don't want to get into that. We will get back to that. I think fairly soon when we are getting into this one. It can't be too far away, obviously. I think Howard was saying that there are some players talking about 1 to 2 years. So I think that it cannot be too far away before we go out in commercial. And then, of course, the volume production goes in steps, as always. It always goes in step, as we have seen when we start a new technology.
One more question, if I may, about your ultrasound technology. Could that be applied in smart cards?
I think for smart cards, let me think. I haven't been asked that question before, Rolf, but I think my first would be that the capacitive smart cards. My first answer would be that this will the cost levels of a smart card. You know what a card costs. And simplicity and ease of use with what we can bring, the manufacturing capability which is there to do, I think capacitive is the best for smart cards for sure now. It's very hard for me to imagine that we could beat the performance of the capacitive sensor that you bring in cost efficiency, manufacturing capability as of existing today already. I mean, if you look at the volumes that have been able to produce in the mobile phone industry and the price, even if ASP, we discussed this year, as you all know very well, minus 30%, around minus 30% this year in ASP decline, to be able to do that kind of ASP decline as well, right, in an industry shows you how extreme capabilities has been taken into the capacity and how the cost level and the price level has moved, right? So I think it's very, very hard to beat that for a card, because the card is, it's so cost efficient, the card already.
Yeah, I can add on top of that. Early on in this ultrasonic technology that we started to develop, we decided that we are developing it's not any fingerprint sensor. This is going to be an in-display fingerprint sensor. And all the decisions we made is to tune towards in-display fingerprint sensing. So that's the goal that we have with this technology.
They will coexist.
Okay, thank you.
Yeah, thanks, Olof. And I think with that, I think with that time is up. It's 4 minutes past the schedule. We wanted to be fast and efficient and give you a view. Thank you, everybody, for here, online, for joining. I hope you have had a good 2 hours with us. I've enjoyed to have so many people. And also, once again, we will get back with more about what we are doing in these exciting times. I hope you've seen a bit of what the journey Fingerprint Cards is on, why we wake up with a big pulse and a lot of energy every morning when we get to work with these brilliant engineers. And thanks for joining us once again. You all have a very good day and evening and morning, depending where in the world you are. It's been a pleasure having you along. Thanks a lot. Take care, everybody. Bye now.